My name's Ashley Liger, and in this video I'm going to talk about polar and nonpolar molecules. So what does it mean to be polar? A polar molecule has an unequal sharing of electrons, which could be due to a difference in electronegativity. Polar molecules also have dipoles, as shown in these images, which I'll talk about in a moment, and they are usually more unstable than nonpolar molecules due to these dipoles. There are compounds all around us that are polar, and one of those is water. Water partakes in multiple behaviors that allow us to survive, so let's first explore what makes this molecule polar. So this is a water molecule, and as you can see, there are 2 hydrogens and 1 oxygen. If you look at the periodic table, you can observe where oxygen and hydrogen are located. And just for a quick review of electronegativity, we know that it increases, for the most part, across a period, and for the most part decreases down a group. However, this pattern isn't completely accurate, so it's helpful to remember Fonkelbresch. The more to the left the letter is, the more electronegative it is. And as you can see, fluorine is the most electronegative element on the periodic table, then follows with oxygen, nitrogen, chlorine, bromine, iodine, sulfur, and hydrogen. So if we look back at our water molecule, we can recognize the fact that oxygen is much more electronegative than hydrogen. So now we can add in our dipoles. As you can see, the more electronegative element gets the partial negative charge or dipole, and the least electronegative element gets the partial positive charge. This is because oxygen has a very strong attraction to the electrons of the hydrogen, and it's almost as if it's trying to steal them. This dipole makes water a polar molecule. So now that you are able to recognize what polarity is, it is also important to know why it is important. Polarity contributes to important properties of water that I'll quickly brush over. They are cohesion or adhesion, hydrogen bonding, high specific heat, capillary action, and the ability for ice to float, as well as its ability to act as a good universal solvent. Life would not be able to survive without the ability for water to do such things, which is why polarity is such an important concept. Here are some more examples of polar molecules. I'm going to revisit this one because there is an exception. It is actually non-polar. But this molecule is polar, and as you can see, it has these dipoles, or partial charges that create the dipole. So this one will go in this direction, there'll be another one here, and another one here. With this molecule, there are 4 dipoles, and because it's a tetrahedral shape, they sort of cancel each other out and it becomes nonpolar. Now that you understand polar molecules, let's talk about nonpolar molecules. Nonpolar molecules do not have strong dipoles, but instead can have dipole moments. But this is more of a discussion when talking about intermolecular forces. They are more stable because they can't form super strong intermolecular forces, but instead form LDFs, which are London dispersion forces. But back to the basics, it's pretty easy to notice that this one is nonpolar because it doesn't have any charges anywhere on the molecule, versus water, which is polar, has these partial charges. Oftentimes, nonpolar molecules will be hydrocarbons, which is basically just a combination of hydrogen and carbon. They don't form dipoles because hydrogen and carbon don't have a very large difference in electronegativity, and the element themselves is not very electronegative. So let's take a look at a more complex photo. Here you can see that there are some polar bonds, but then there's also some non-polar bonds. it doesn't necessarily mean that the whole molecule is polar, but in this case it does. This is a polar bond because the oxygen and the hydrogen have a large difference in electronegativity, and so there's a dipole on this region right here. We can even get even more complicated when talking about polar and nonpolar molecules, and note that this whole region right here is nonpolar, while there are some polar areas over here. And this is an image of a phospholipid, but that's not exactly important for this concept. And we're just going to quickly brush over a really important concept known as like dissolves like. This concept can get more confusing, but here are just some of the basics. Basically, polar molecules dissolve in polar solvents, and nonpolar molecules can dissolve in nonpolar solvents. This explains why vinegar and oil don't mix, or water and oil. The reasoning behind this is because oil is nonpolar and water is polar. It's because of their difference in polarity, and they don't form new bonds with these molecules and thus cannot mix. Alright, that's polar and nonpolar molecules, and I hope that was helpful.